In this video, we will explain how an undiagnosed failed electroviscous fan clutch often leads to repeat air conditioning compressor failure or a customer complaint of poor air conditioning performance on a 2003 or later Dodge truck with a Cummins diesel engine. We will also discuss how a failed pressure transducer and incomplete compressor replacement procedures also contribute to compressor failure. Over the past several years, we have noticed a sharp spike in repeat compressor failure on these vehicles. As in many cases of repeat compressor failure or an ongoing customer complaint of poor air conditioning performance, the root cause of the original failure is usually not identified. These vehicles use a computer-controlled electroviscous fan clutch. Fan clutch engagement is controlled by the powertrain control module via pulse width modulated solenoid in the clutch. As pulse width increases, more viscous fluid is metered into the working area of the clutch to create a viscous coupling and therefore increase fan speed. A Hall effect sensor in the clutch reports fan speed back to the PCM. The computer considers several inputs to precisely control fan speed to match the cooling demand, including coolant temperature, oil temperature, transmission temperature, intake air temperature, ambient air temperature, vehicle speed, and the actual fan speed itself. When the air conditioning is on, the high side pressure transducer is a major input to the PCM in determining fan speed. As high side pressure increases, fan speed increases. So what goes wrong? The key thing to understand is that even a minor change in condenser airflow can have a huge impact on air conditioning performance, but under most circumstances will have little or no impact on engine temperature. A simple demonstration will illustrate this point. Here we are running a Dodge Ram 2500 with a 6.7 litre diesel engine with the AC on. It's a mild day, the temperature is only 75 degrees. Now watch what happens when we briefly block off and then unblock condenser airflow. AC head pressure increases rapidly and then decreases, but there is no change in engine temperature. This is why the root cause of compressor failure, which is insufficient condenser airflow, often goes undiagnosed on these vehicles. Because there is no evidence of engine overheating, an airflow problem is never suspected. Now look at the temperature gauge on this vehicle that came in with a failed compressor. The gauge is right in the middle of the normal range with no evidence of engine overheating. There is no obvious reason to suspect an airflow issue. Yet there is a code set for the electroviscous fan clutch. In fact, the fan clutch was simply windmilling. It was not actively drawing air through the condenser radiator. Another reason why the fan clutch is not suspected is because the malfunction indicator light is not on, even though there is a code set. This is a Class C code which does not turn on the mill. It's important to note also that in many cases a failed fan clutch does not even set a trouble code. Remember, even if it has failed, the fan will still be turning. This makes it difficult to tell with the naked eye whether it is actually engaged or not. Use the scan tool bidirectional function to command the fan on. Fan speed should increase on the scan tool and you should hear a noticeable increase in fan noise. The takeaway, of course, is that a small change in airflow can have a big impact on air conditioning performance. An undiagnosed electroviscous fan clutch is often the cause of repeat compressor failure on these trucks. The other common and related failure on these trucks is the pressure transducer that reports high side AC pressure to the PCM. This is a key input for viscous fan control when the AC is on. A basic check for this sensor is to compare manifold gauge pressure with the pressure indicator on the scan tool after the vehicle has been off for a while and the pressures have stabilized. They should be within a few pounds of each other. This is not a conclusive test, however, as it only checks the transducer accuracy at rest. Because the transducer is on the discharge line before the condenser, and the service port is on the liquid line after the condenser, gauge pressure and scan tool pressure may be somewhat different with the AC on at higher pressures. The other issue that results in repeat compressor failure on these trucks relates to the orifice tube. The orifice tube is not located at either end of the liquid line as you might expect, but instead it is crimped or captured in the middle of the liquid line below the battery and air filter box. Because the orifice tube cannot easily be found, it is often assumed that it is a TXV system. with the TXV inside the cabin. Because of this confusion, the orifice tube is often not replaced following catastrophic compressor failure, and the liquid line becomes even more restricted with each successive failure. In summary, for successful compressor replacement on a 2003 or later Dodge Cummins Diesel, you will need to check for electronic viscous fan clutch codes, use the scan tool bidirectional controls to check the electronic viscous fan clutch function, check the accuracy of the pressure transducer, and at a minimum, replace the liquid line, which includes the orifice tube, the accumulator, probably the condenser, and thoroughly flush all components not being replaced, including the evaporator. Thank you for watching.